The landing gear on airplanes isn't essential to flight. However, it is essential for smooth landings. Development of flight is one of the engineering marvels of the 20th century. However, one often overlooked facet of flight is the ability to bring the plane back down to the ground safely. The earliest planes had landing gear that was fixed in place. The retractable landing gear that is now commonplace on aircraft was first developed for Glenn Curtiss's Triad airplane in 1911. The Triad was amphibious, so the retractable wheels were used to help it take off or land on water. By the 1930s, retractable landing gear was being developed for other aircraft models, bringing with it an increase in speed and efficiency. In fact, today, landing gear mechanisms equate to between 3 and 5% of the total weight of planes and can also take up a large percentage of the total maintenance time for airplane mechanics. The need to design landing gear with minimum weight, minimum volume, reduced life cycle costs, and short development time means that most landing gear components are also made by specialty suppliers due to the complexity and precision needed for landing gear parts. The main strut of retractable landing gear may be machined out of high-strength steel. This strut varies in size on different aircraft and is the most important component of the landing gear. It supports all of the forces involved in the landing process. Attached to the main strut are the wheels, which in most airliners also include brakes to help slow the plane down upon landing. On retractable landing gear, the wheel assembly attaches to the main strut, which can be folded into the plane using internal hydraulic motors. There are also redundant systems and a manual release mechanism in case of emergencies. Retractable landing gear will generally be deployed at about 4 miles out from landing. The landing gear is a huge source of drag, so pilots avoid deploying too early. But they also need to have enough warning to abort the landing if there is a landing gear malfunction. But how do pilots know if their landing gear has been deployed? Pilots confirm that their landing gear is down and locked from 3 indicator lights that operate from sensors. Some planes also have a type of periscope in the cockpit that allows pilots to look through the bottom of the plane and see if the landing gear is deployed properly. Many smaller planes have static, non-retractable landing gear, where the wheel is rigidly attached to the main strut and stays in place the entire flight. In both cases, the structure of the landing gear and the wheel itself are both made to withstand the significant shock forces from the landing process. Often, oleo strut, which is a pneumatic air-oil hydraulic shock absorber, is used to take the impact. Smaller planes may have solid shock absorbers. However, there are more landing gear types than just static and retractable wheel designs. There are also skis, monowheels, detachable wheels, floats, and more. All of these different types come into play in different airplane designs and applications. Seaplanes, for example, don't use wheels to land. Rather, they use buoyant skids or floats that allow the plane to glide over the water's surface and eventually come to a rest. Because the skids are buoyant, they keep the plane above water and stable. Some smaller aircraft will also use skis or skids on land. Planes that use this design will mainly be smaller aircraft that land on slippery surfaces, such as snow or ice, gliders, or planes that don't have engines and rather just glide through the air. Some glider designs use a monowheel to land. This is simply a singular wheel mounted on the underside of the aircraft that the plane can touch down on. This works because the craft is so light and normally lands on grassy surfaces, rendering the landing process far smoother than other larger aircraft. One interesting note about wheeled landing gear is that they can't just be filled with any kind of air. Rather, in most cases, they are filled with pure nitrogen in order to mitigate any risk of them exploding and catching fire on landing. However, while filling the tires with nitrogen does help keep them from catching fire, if tires pop, a plane won't come down safely. Occasionally, landing gear tires do pop due to the forces from landing, and when this happens, the pilots have to fight to bring the plane to a stop. Many pilots have been able to do this safely, but there have unfortunately been deadly accidents due to the failure of landing gear in the past. Landing gear designs are diverse, but one thing connects each different type: the need to land aircraft safely and ensure that the future of air travel is bright.